Okay, so in this video we want to look at factorization. So for Leaving Cert higher level, there are 6 types of factorization that you need to know and you need to be able to do. The good news is that you've already seen 4 of these already at Junior Cert, and really we're just looking at 2 new types of factorization. Now, the factorization questions we see will be that little bit harder, and what we use factorization for will be a little bit harder, but the basics are still the same. So there are 6 types of factorization, like I said, and these are highest common factors. So this is where we find what is common to the terms and we take it out. The second is grouping, and grouping happens where there is 4 or more terms. And what I mean by terms are pieces in the expression. So if there is 3, if there is 2 terms, it doesn't make sense to put them in a group. The smallest number of terms that it makes sense to group them is really 4. The third then is quadratic trinomials. So the method that I'm going to use here is the guide number method. You may be using other methods and that's absolutely fine. The guide number method tends to be a little bit easier when we move on to the harder versions of these questions. So just make sure that whatever method you are using that you're comfortable with. Now the fourth type of factorization we need to know is the difference of 2 squares. There is a formula for this and I'll show you that in a second. The fifth type of factorization, and this is where we're hitting our new types of factorization, and it's called the difference of 2 cubes. And what we mean by cubes is a cube number, and that is a number that basically has been created by some number multiplied by itself and multiplied by itself again. For example, 2 by 2 by 2, which is 2 cubed, is equal to 8. So 8 is a cubed number. Similarly, we're then going to look at the sum of 2 cubes. So these formulas are very similar. If you want to look at the formulas and see how they differ, it can make it a little bit easier. So you're not really learning 2 formulas, you're learning 2 versions of the same formula. So the formula for the difference of the 2 squares, so it's here, and what we mean by square then is a square number. So a number that is created by another number multiplied by itself. So the square numbers, and you really should be aware of them, are 1, 4, 9, 16, 25, 36, and so on. So the formula is here now. If you have 2 squares and difference is subtract, so we have a subtraction between them or a minus sign, the bracket, so the factorization looks like a plus b in one bracket and then a minus b in another bracket. So the formula for the difference of 2 cubes then, so where we have 2 cube numbers, again we're talking the difference, so subtraction. In the first bracket it's a minus b, and one way to look at this is in the first bracket the sign also always follows what we've been given in the expression. So if we are doing a difference of 2 cubes, the first sign is a minus. Okay. In the second bracket it's a squared, so the first term squared minus ab plus b squared. So we'll look at how that actually works with some examples. So the sum of 2 cubes then, the formula for that is just here. So it's very similar. So like I said, for the difference 2 cubes, in the first bracket that sign follows what we're given. Since this time we're doing the sum of 2 cubes, so when we add 2 cubes, the first sign that we have in that first bracket is a plus. In the second bracket then, our first sign is a minus, and then the last sign is always a plus. Okay, so you can think of it as the first sign in the first bracket follows what we're given. The second sign is the opposite to the first sign, and the last sign is always a plus. Again, we're going to look at how this actually works. So let's move on to an example. The first example we're going to look at is highest common factor, and that's seeing what is common. Now it's important to remember that it may be a number that's common, it may be a letter, it may be both. Okay, so this example here, we've been asked to factorize fully 4ab squared minus 12ab cubed. If it helps, you can write this as 4ab because that's what b squared is, b multiplied by b, which in algebra we don't have the multiplied sign, we just write them side by side, minus 12ab b. This can often make it a little bit clearer, and even if you want to start using this method at the beginning and then as you get more used to it you'll be able to see what's common. So I suppose this step isn't necessary for everybody, but if you think it might help, then of course put it in. So hopefully from this you'll be able to see that number wise there's a 4 common to both. 4 divides into 4 and 4 divides into 12. So let's say 4 is common. But remember the name of this is the highest common factor. So it's not just pick any factor that's in there, we need to pick the highest. The 4 is there. There's also an a that's common. And there's also 2 b's. So that's going to be b. Okay, we'll clean that up in a minute. So if we've taken out the 4, the a, and the 2 b's, what we're left with is 1. Remember that this has to multiply back to what we started with. So what we're effectively doing is we're doing a division. So when we divide 4abb into 4abb, we're left with 1. Be really careful with that. So then what we can do is 4 multiplied by what will give me minus 12, and that's minus 3. The a has been taken out, a b has been taken out, and a b has been taken out, leaving us with just 1b, like this. So going to just need to clean this up a little bit. So we'll have 4ab squared bracket 1 minus 3b. And that is factorized fully. Okay. So we're going to move on to the next example. And this example is grouping. So as you can see, there are 4 terms. It's important for us to ensure that we group them in a way that there are terms common. So if I look at the first 2, there's definitely a number common. There's also a letter common, so they look okay. But then if I look at the second 2, I run into a bit of an issue. As you can see, there really isn't any number or letter that is common. So really, we shouldn't group them in this way that it's written. It is absolutely fine to move our terms around to make them a better fit. Okay, so what I'm going to do is I'm going to keep my 6ab here. I'm going to move this minus 9b squared up here because there's definitely something common within the numbers. There's also something common within the letters, so that should give us a good answer. Then I'll have my plus 12bc minus 8ac. So we're now looking at this group and this group. So what is common here? Well, there's definitely a 3 common. Again, like our last example, if you want to write this 9b squared as bb, please do. I'm going to just take out one of the b's. I can see there's a b here, and this will have 1b there. That's common. That leaves me with a 2a here. Remember, 3 by what gives me 6? And I've taken out a b, so I just need to put in my a minus 3b. And with my second group here, I'm looking to see what's common. So number wise, there's a plus 4 common here. and letter-wise there's a C. So when I come along, I then see I have 4 by 3 gives me 12, there's a B, and 4 by minus 2 and gives me 8, and then there's an A. Now at this point it's really important that I check my brackets, and my brackets should always be the same. So here I have a 2a minus 3b, here I have a 3b minus 2a. So they look somewhat similar, but they are not the same, so something has gone slightly wrong. My signs in this bracket do not match the signs in this bracket. The signs are the opposite. Here I have a plus 2a, there I have a minus 2a. Here I have a minus 3b, here I have a plus 3b. So the way I rectify that is, really I need to take out a minus 4c here. That will give me a minus 3b here and a plus 2a here. Okay, does that still give me what I started with? Well, minus 4c by minus 3b, minus multiplied by a minus gives me my plus, my 4 by my 3 gives me my 12, and my c by my b gives me my bc. So that's perfect. Here, my minus 4 by plus 2 gives me my minus 8, and my c by my a gives me my ac. So by changing this sign here, I've made my brackets match. Now, it's not a big problem for us that they're written in the wrong way, because if I have 2 plus 3, it's the same as 3 plus 2. So order isn't necessarily important to us. However, the signs are important. But now I have a positive 2a here, a positive 2a here, a minus 3b here, and a minus 3b here. So just to make it look a bit cleaner, I'm going to rewrite my brackets so they're the same. So we have minus 4c, and I'll write 2a minus 3b. So now all looks good. And this is where we basically take out what's common again. So if you notice, this bracket here is the same as this bracket here. So this again is a common factor. So we take that out. So 2a minus 3b. And when I take that out, I'm left with a 3b minus 4c. So that's where we're combining the brackets. And I suppose sometimes we combine the brackets and we might understand why we're doing it. And what we're actually doing is taking out what's common again. So that is this particular expression factorized fully using grouping. So the third type of factorization we want to look at is to factorize quadratic trinomials. So you'll recognize these because there is an x squared that appears in them. They're usually in the form of having an x squared, an x, and then a constant. So the method that we're going to use is called the guide number method. So the guide number is actually created by multiplying the first and the last numbers in the quadratic. Now it's really important that the quadratic is written in the form of x squared, x, and a number. So if you think if you're driving down the road and the car is guided with these lines, the guidelines on the road, they appear kind of either side of the car. So similarly here, it appears at each end to help guide us through. So the first thing we're going to do is we're going to calculate the guide number. So the guide number in this case is going to be 2 multiplied by minus 19, which is a minus 38. So because it is a negative, we know that when we get the factors will have different signs, because we know that different signs will multiply to give us a minus. So a plus by a minus or a minus by a plus. So we've already used 2 and 19 to get here, and we're trying to find a set of factors which basically add to give me minus 17. And if I used 2 and 19, where the 19 is a negative and the 2 is a positive, they will actually add to give me minus 17. So that's exactly what we're looking for. So our next step, now that we have got our guide number and we've factorized our guide number, is we are going to rewrite. Okay, and specifically we're going to rewrite this bit. We're going to turn this into two terms. So what that looks like for us will be 2x squared no, apologies, technology has come a little bit haywire. So we'll have 2x squared plus 2x minus 19x minus 19. So now we have four terms. All we've done is we've rewritten the minus 17x as plus 2x minus 19x. So we haven't actually changed it. We've changed how it looks, but we haven't changed the actual expression. And that's important to remember because we can't change what we've been given. It's similar to if you go into a shop and you change a €20 note for a €10 and 2 fivers. So it might look different. We have more, but we haven't changed its value, and that's what's happened here. So now that we have four terms, we can actually use grouping. So we can group the first two together and we can group the second two terms together. So we'll see what's common, and in the first group there's a 2x common, which leaves me with an x plus 1. In the second group then there's a minus 19 that's common, and that leaves us with an x, and be careful with your signs here. A minus 19 by what gives me minus 19, and that's a plus 1. So now is our check. When we have when we are using grouping as a method of factorization, we always check to ensure that our two brackets are the same. In this case they both are. We have an x plus 1 and x plus 1. So that's now common, so we can take that out, and that will leave me with a 2x minus 19. Okay, and that is a quadratic trinomial, fully factorized. So some people skip directly to this step and use trial and error. That's absolutely fine if that's the method that you're sticking with. Trial and error can be a little bit more difficult, but just be really careful and ensure that you're double checking all your work, and that should be absolutely fine. Any of the examples that I'm going to do, I will be focusing on this guide number method. So the fourth type of factorization, and again you'll have met this already, is called the difference of two squares. And if you remember earlier, we had this formula. So where we have a squared number minus and another squared number, we can just take what is effectively the square root and add it to the square root of the second term, the square root of the first term minus the square root of the second term. So my advice on these are to really write them in a form that will help, and I've jumped straight to a tougher type of question with both numbers and letters. So instead of just having 36p squared, it's good to write it as something to be squared. So 36 is a square number, and if you want to check if you're not sure where it comes from, you can use the square root button. So that's the square root of 36. You can use that in your calculator, and you do get that as 6. So we know that this is 6p, all to be squared. So this little squared here relates only to the p. It does not relate to the 36. So that 36 is already some number squared, and that causes a lot of problems. So this method of writing them in a bracket to be squared first can take away some of those issues. So similarly, let's do the same thing here. So we'll have a minus. Now again, square root of 100, if you're not sure what that is, you can put it into your calculator, and we'll discover it's 10q all to be squared. Now we come to use our formula. So our formula is here. So now in this case, my A is 6p and my B is 10q. So what I have is 6p plus 10q, and in my second bracket I have 6p minus 10q. And that is my difference of two squares fully factorized. So the fifth type of factorization, and this is new to us this year. This is one that it only appears on the higher level course. You do need to know the formula. The formula is not available, and the formula that we saw earlier. So it's a cubed minus b cubed is equal to bracket a minus b, close your bracket, open your bracket, a squared plus ab plus b squared. Okay, my advice is when you are doing these questions, write your formula up here. If something goes wrong, at least somebody correcting your work can see that there is an understanding there that you have your formula. So like in the difference of two squares, the easiest way to start these is by writing each term as a bracket to the power of 3. Okay, so a to the power of 3 is just going to have a. That's fine. And in this case, what number multiplied by itself and multiplied by itself again give me 64? Well, we can use what's called the cubed root, and this again is on your calculator, and it's 64. And when you put that into your calculator, it should give you 4. So 4 by 4 is 16. 16 by 4 gives me 64. Okay, so the way to check for a cube is this cubed root. So where a square root is the opposite of a square number, the cubed root is the opposite for a cube. So in this bracket we're going to have 4a to the power of 3. And again, if you weren't sure about one, hopefully we are, we could use that cubed root and it will give me 1. So this is going to be 1 to the power of 3. Remember, 1 multiplied by 1 multiplied by 1, you can keep multiplying it by 1 and it will still stay as 1. So now using our formula, we'll have 4a, so the first term, minus 1. I'm then going to have, and be really careful with this, it's 4a all to be squared. So it's not enough just to write 4a squared. It's 4a all to be squared plus 4a by 1. So remember AB, when we're talking algebra, writing them side by side means multiply. And then we have 1 squared. So we need to do a bit of a cleanup. You wouldn't get full marks for leaving it like this. So our first bracket is fine. Our second bracket, 4 squared is 16. So we'll have 16a squared plus 4a by 1 is just 4a. And 1 squared is just 1. And that's our answer. Be really careful with these questions because I see a lot of people getting to this point or even this point and starting to multiply out the brackets again. Remember, factorization, we're trying to find the factors of an expression. And factors are things that multiply to give us the expression. So the implicit, what's already there, so multiply. What we're actually looking for are these brackets. So our answer should be brackets. there's no need to multiply them back. If you multiply these out, you should get back to where we started. So there's no need to do that. So our last type of factorization that we're going to look at is the sum of two cubes. So it's very similar to the difference of two cubes, and we talked about that earlier about how the two formulas are very similar. So our formula here is a cubed plus b cubed equals a plus b, and a squared minus ab plus b squared. So the only things that change are really those two signs. So the first bracket always follows what's given. So if we're doing the sum, it's always plus. If we're doing a difference, it'll be minus. And then this sign here is always opposite to that. The last sign is always a plus. Okay, so using a very similar method we had in the last question, we're going to write both of these terms as something to the power of 3. So we can use our calculator if we're not sure. So to get the cubed root of 8 is 2. And the cubed root of 27 is 3. So you will get used to these. If you're finding at the moment that you don't know when you're using your calculator, that's fine. You will become more and more familiar with it. It's a good idea to try maybe guess what the number is and then double check it on your calculator. Don't just reach straight for your calculator. Try to train yourself to see, can you figure out which number it might be. And then if you're checking on the calculator, it's not like your question depends on it. So there's always a double check. So here we'll have 2a, here we'll have 3b, and then we fill into our formula. So we have 2a plus 3b. Then again, like the last time, remember it's 2a all to be squared. So that full term has to be squared. It's not enough just to write 2a squared. So then we have 2a by 3b. And then we have plus 3b squared. So we need to clean this up. It's not enough to leave it like this. So 2a plus 3b. 2a to be squared gives me 4a squared. 2 by 3 gives me 6. A by b gives me ab. And 3b squared gives me plus 9b squared. And that's finished. Okay, so that is a sum of two cubes fully factorized. So now, there are all the types of factorization that you need to know. However, there's some variations that you might see that it's important that you're able to do. The first one I'm going to show you is a multi-step factorization, and these are very common. So if you take a look at this example here, so the question is factorize fully 3x cubed minus 648. So on first glance you might say, oh, there's an x cubed, so it must be the difference of two cubes. However, be really careful. There's a 3 here. This is not a cube number. If we wanted to check, we could put it into our calculator, and it gives us something pretty nasty. So that's basically telling us it's not a cube number. So although it looks like a difference of two cubes, it's not. The good news about factorization is that only one type will ever work. So it's not a case of, oh, I have 3 types that will work, which one is the best. Only one type of factorization will ever work. So if you know your 6 types, you can actually work through them and see, well, does this work, does that work? So we'll start at the start. So the first one we had was highest common factor. So is there something common to the first and the second term? And the answer is yes. So there is actually a 3 common. And if I take out a 3, I'm left with x cubed minus 216. Now, I'm looking at something in the bracket that looks like a difference of two cubes, but I'm not sure. So let's go and check. So if I do the cubed root of 216 and I put it into my calculator, I'll discover that that gives me 6. So it is actually a difference of two cubes. So in this case, it wasn't enough just to factorize once. We now have to factorize a second time. So let's write this out like we usually would. So we'll write the first term to the power of 3 minus, and this is 6 to the power of 3. We need to know our formula. So our formula for difference of two cubes is a cubed minus b cubed equals a minus b. Remember that sign follows. A squared, since that was a minus, this is going to be a plus, ab plus b squared. So let's fill into our formula. Remember, this 3 has to stay. So we have x minus 6, x squared plus 6x plus 6 squared. So let's clean this up a bit. X minus 6, x squared plus 6x plus 36. And that's our answer. So often we might see an expression that looks like difference of two squares, looks like difference of two cubes, looks like the sum of two cubes, but it's not exactly. That's usually a sign that there is some other type of factorization to do first. Okay, so here is example 2, and it's an important one to have. So it's a special quadratic trinomial. And why it's special is because unlike the quadratic trinomial that we saw earlier, this actually has not only x's but also p's. So this is linking back to Pascal's triangle. So I suppose in order to really fully understand this, you do need to have some understanding of Pascal's triangle and how it works. A short way of squaring a bracket, so let's do one here just as an aside, plus 3. So if I wanted to square a bracket using Pascal's triangle, I would square my first term plus 2 by my first term by my second term plus my last term squared. So I get x squared plus 6x plus 9. So that comes from Pascal's triangle. My advice would be that you write out your brackets twice and you do your multiplications to ensure nothing goes wrong. But it is useful to have an understanding of this. So to come back to the example we actually have, we have an x squared, a plus 2px, and a plus p squared. So you might notice that this actually follows from Pascal's triangle. So where my first term is x, my second term is p. So what this actually factorizes to is x plus p and x plus p, which is x plus p squared. Okay, so we can tell that by the first term squared, the second term squared, and a 2 by the first and the last. Okay. So if you wanted to try and apply guide number to this, which you can, we would need to just be very comfortable with our algebra. So let's look at this as a guide number question. So our guide number in this case is p squared. So what are the factors of p squared? Well, it's p by p. Do they add to give me 2p? Yes, they do. So let's write that out. We have x squared plus px plus px plus p squared. I'm coming along to do my grouping. So there's my first group. There's my second group. I look for what's common. So in my first group, I have an x, which leaves me with an x plus p. And in my second, I have a p, which leaves me with an x plus p. My check is, are both my brackets the same? Yes. So I can take that out, my x plus p, and then I have an x plus p. So same answer. So you can either have an understanding of Pascal's triangle and recognize this as being something squared and working out what that is, or you can apply your guide number method. So I want to just go through a tougher trinomial here, and I suppose it is really important that you were able to deal with questions like this, because again, at higher level, this is the type of question you are more likely to see. So here we have an x to the power of 4, an x squared, and a number. So there's definitely nothing common to all of these. There's only 3 terms, so we can't do grouping. It looks kind of like a quadratic. However, we have an x to the power of 4, and we've always said quadratics are x squared. So let's park that one for a second. Let's go through the rest of our factorization. We have difference of 2 squares, which this definitely is not. We have difference of 2 cubes, which this definitely is not. And we have the sum of 2 cubes, which this definitely is not. So we kind of tried all types of factorization and none have worked. But it does really look like a quadratic. So the problem is, instead of an x squared, we have an x to the power of 4. Instead of having an x, we have an x squared. So what hopefully you are able to recognize is that it does follow the same form as a quadratic. However, we're going to use a different letter. So if I said, for example, y is equal to x squared, then y squared will equal x squared squared, which is actually equal to x to the power of 4. Now, what I'm going to do is, instead of x to the power of 4, I'm going to rewrite that as y. And minus 7, instead of x squared, sorry, this should be y squared. Instead of x squared, I'm going to use just y minus 18. So I've rewritten this using y's, and I now have what is exactly a quadratic trinomial. And I'm going to use my guide number method to solve this. So my guide number is minus 18, so my factors are going to have different signs. So my factors of 18 that I could try are 9 and 2. So 9 and 2 will give me my minus 7. So I'll need a plus 2 and a minus 9. So y squared plus 2y minus 9y minus 18. I'm going to come along and group these. So I have y common in the first instance, and I have minus 9 common in the second. Again, be careful with your signs. Minus y by plus 2 will give me minus 18. Really watch your signs here. My check is, are both brackets the same? They are, y plus 2, and that leaves me with a y minus 9. Okay, so we were not given a y in the question. We created that y, which is fine to do, but we need to sub back in. So remember, y equals x squared. So here I'm going to have an x squared plus 2, and here I'm going to have an x squared minus 9. Now, you might notice as we subbed back in that the second bracket here was actually a difference of 2 squares. So although we have done our factorization, we now need to factorize this bracket again. It's important to remember we do not ever factorize a square number plus another number. It's the difference of two squares. It has to be a negative. So x squared plus 2. And then using this difference of two squares, I'm just going to come over here to do it just so we have a bit more space. Minus, this is 3 squared. So we're going to have x plus 3, x minus 3. And we're just going to replace that here. And now that is factorized fully. So we basically substitute in another letter, and we could use any letter we wanted here. So I could have called that A instead of Y. I could have called it B, but it's just we're so used to working with X and Y's when it comes to quadratic, it's good to stick with that. Okay, so by changing our x squared to a y, we then create a quadratic in the form we're used to. We were able to factorize it using the guide number method. And then the important step again to remember here. So just remember to sub back in at this point. Okay. So this is the last example that we're going to do with factorization. And this is where we have more complex terms. And what I mean by that is where it's not just one term minus another term for the difference of two squares. In this example here, I have one bracket squared, so it must be a squared number, minus and another bracket squared. So what we actually have here is the is a difference of two squares, and we need to factorize it as such. It's actually written in the form that we would write it anyway, a bracket squared minus another bracket squared. So we can go straight into it. If you remember, our formula for difference of two squares is a squared minus b squared equals a plus b, a minus b. So we're going to use that formula. So in the first bracket, we're going to have x plus 2 plus x plus 3. And in the second bracket, we're going to have x plus 2 minus. And this is where you have to be really careful. The b is x plus 3. Now, both of those terms need to be subtracted. So the easiest way to do this is to first show it in a bracket. So let's clean up our first bracket. We'll have 2x plus 5. And in our second bracket, we'll have x plus 2 minus x minus 3. So be really careful with this. We basically have a minus in front of both of these terms, so we have to get minus x and a minus 3. Think of it as multiplying both by a minus 1. So let's clean up our second bracket, 2x plus 5. Here we have an x minus an x, that will cancel, and a plus 2 minus 3 is a minus 1. So an easier way to write this is minus 1, 2x plus 5. So the more complex terms, and we usually see this with regards difference of two squares, just be careful then with the negative or with the minus bracket. If you had a complex term like this, in the form of a quadratic, we could use the substitution method that we had in our previous example. So hopefully that gives you a good overview on the factorization. I will do a separate video on the uses of factorization. So when we move into higher level questions, it is less common to see just a simple factorized question. However, you are expected to use it. So that is the algebra fractions video. So if you want to move over there next, that will be a good follow on from this.